Hey guys, welcome back to my channel. So today let's talk about the regression with the binary regressor. Okay, how to interpret the coefficient of a binary regressor. Many of you ask me that question, and that's a relatively straightforward question. So I can interpret that within 10 minutes, I think. So y is a continuous variable, but x is a binary. How to interpret the y-intercept and the coefficient of this binary variable? You know that if this regressor is binary, we don't interpret the coefficient as a slope, right? We don't interpret the coefficient as the effect on y of a unit change in x. We interpret it as the difference between two conditional means or two group means, right? So, and yeah, let's talk about that, right? How do we interpret the coefficient of binary variable, which can serve a very good preparation for my future topics, which is perfect and imperfect multicollinearity, and also OLS regression or OLS regression. Yeah, let's get into it. So let's suppose we have very simple regression. Y equals, let's suppose this is earnings, equals B0 plus B1, a measure of sex or gender, so F, plus error. So now the F equals 1 if the person is a female. It's 0 if the person is a male. Okay. Let's talk about how to interpret this coefficient B1, and how to interpret kind of intercept, y-intercept B0. Okay. So this is a little bit different from a regression with a continuous regressor, like compared to this one. B0 plus B1x plus error. Let's suppose this is let's suppose this is earnings, and this is education years of schooling or your height in inches, right? So, you know, if this is the case, x and y both are continuous. We know that, right? So let me move to this side a little bit. So have y, x, and for each observation, you have that. The data is 1, 2, 3, 4. And y1, y2, y3, y4. For each observation, you have a value for a variable y. For each observation, you have a value for variable x. Right? We said that before. So for each observation, you can have a 1 point on this xy coordinate. So like the x1, y1, x2, y2, x3, y3. So you have n observations, you have n points on this xy coordinate, right? And then we use OLS, ordinary least squares, to get this regression line. We'll talk about OLS in next video. Okay, so now it's like this. And then any point along this line is a predicted value of y or expected value of y given a value of x, right? That equals y-intercept B0 plus B1 times x. Right? And that's it. So you can use this OLS regression line, to describe the relationship between height and earnings, right? And the B0 is just y-intercept. It's like, what would be the average earnings if this person's height is 0, so which is B0, right? Of course, we assume that expected value error given x is 0. Otherwise, we can't interpret this B0. So we just assume this is true. That means that there's no relationship between error and x. Okay, so we interpret the y-intercept as the expected value of y when x equals 0. But we know that this person's height can be 0. So now there's no economic meaning of this y-intercept for most of the case. So that is, you can interpret B0 outside the range of the meaningful value of x. So the value of B0 is just help us to identify this regression line. Okay, and the slope is measured by B1, and this B1 gives us a relationship between x and y. That is slope, which is rise over run. Right? Let me use a different color. So that's changing y over changing x is measured by B1. Basically, is what would be the change in earnings if there is a 1 unit change in height, right? So give us the slope, rise over run. So if the height increased by 1 unit, what would be the expected change in y? So this average of y given x plus 1, right, minus average y given x. right? So you get that, and zoom out a little bit, so you get this equals b0 plus b1 times x plus 1, right? Plug x equals x plus 1 into this regression, right? You get the value of y, right? And minus plug x into this regression, b0 plus b1x. You get this b0 cancel out, b1x plus b1 minus b1x is b1. So this b1 give us the change in expected value of earnings when there's a 1 unit change in x, right? It's basically the slope, right? Slope. And if this, we assume there's a linear relationship, that means the effective height on earnings is constant over the value of x. So let's say x increased from 6-7 inches to 6-8 inches, and then you have an expected change in earnings, right? Or 100 inches to 101 inches, you have the same values expected change in y, right? So that's right. So that's, you assume that linear relationship, right? That's how we interpret b0 and b1. However, if we have this binary independent variable, how do we interpret? How do we draw the scatter plot, right? Scatter plot, when both x and y are continuous, we have this scatter like this. Right, you draw a regression line. Again, we'll talk about OLS in next video. But now this variable is binary, it's a dummy variable or indicator, right? So that's how do we draw the scatter plot? To draw a scatter plot, you should have a data, right? So let me draw it here. Okay, so this is the value data, and female, right? 0, 1, 1, 0, 1, 0, like that. You have the value of this variable female, and then you have y earnings, y1, y2, y3, y4. For each observation, we have a value of y. Okay, so now how do you draw the scatter plot? So let me draw it here. And this is y, this is a female, right? So first observation, 0, a value of y. Because female, this variable can only take on 2 values, 1 or 0. So 0, you have 1 value y. Let me use green to make it more obvious. So for a second observation, 1 and a y2 may be somewhere here. Third observation, 1 y3. Fourth observation, 0 y4. 1 y5, 0 1 6. And then you will have the scatter plot look like this, 2 vertical lines. Maybe look like this. It's not, it's a little bit counterintuitive. So let me just make it more intuitive. So, okay, so let me draw it this way. When female 0, that means is male, right? Usually, right? So males are more than female like this. 1 female y1, 1 y3, 0 y4, 1 y5. Right, you have this 2 vertical line like this. Right, this is what the scatter plot look like when you have a binary independent variable. Okay, so now based on this, you draw the OLS regression. Okay, let me use a color yellow. Okay, and then you still have a y-intercept, b0, and a kind of slope, b1, because you can identify this line as expected value of y given a value of x or female, right? Expected value of y given a value of female equals b0 plus b1 times female, right? Which this equals y hat, right? That makes sense? So now, how do I interpret b0 and b1? So in this case, b0 is y-intercept, right? Is the same thing. So it's average earnings given the independent variable female equals 0. So that's b0. Right? So now the b0 give us the average earnings for all male workers. Okay? Average earnings for all male workers. So now it's not like this b0. b0 here does not have any economic meaning because you can have earnings when height equals 0. But when f is a binary variable, usually we have a meaningful y-intercept. In this case is the average value of y when the binary variable equals 0. Okay, because binary variable, because this variable f is a binary variable, that means it can take 1, also take 0, right? Of course, it's a meaningful when f equals 0. It could be go to college, not go to college, right? Or it could mean have a children, not have a children, or in this case, it's a male, female, right? So that's B0 is interpreted as the average value of y when f equals 0, which means male, right? And how to interpret B1? Here, we're not interpreting B1 as a slope or rise over run. It's not like the changing y when female increased by 1. What that mean, right? So we interpret this B1 as the difference between two group means or two conditional means. So the B1, mathematically, they're the same. Average y given female is 1 minus average y given female is 0. Right? That's right, that equals B0 plus B1 minus B0 plus 0, right? If you plug f equals 1 into the regression, you get the expected value of y equals B0 plus B1. And plug f equals 0 into the regression, get the expected value of y equals B0. So difference is B1, right? Graphically, that's this group are female, and this group are male. And then what the difference in earnings between the two groups? Right, is measured by B1. So this B1 gives us the difference between two group means or two conditional means, right? So that's we don't interpret this B1 as a slope. So actually, this B0 give us the average of y, expected value of y when this x variable equals 0, and B1 just give us the difference between two group means. Actually, that means this minus this. But this is a group mean. Conditional. This is the average of y given x equals 0, and this is the average of y given x equals 1. You get the difference. But here, we usually use 1 minus 0, so get this difference is negative, right? So B1 gives us the difference between the average y given x equals 1 minus average y given x equals 0. Okay, so that's how we interpret the y-intercept and coefficient of binary regressor. Hope you find this helpful, and I'll see you in the next video.